Hello everyone, welcome to RHEA's online lunch lecture series. In this lecture, Marc-Elian Bégin CEO at SixSq, the cloud computing company of which a majority interest has been recently acquired by RHEA, will present some of the key activities of SixSq and give us an insight on the latest cloud computing trends. Cloud computing is a big buzzword for the last couple of years, and there are certainly many misconceptions about what it does, the benefits, and the security involved in this innovative domain. So before I give the floor to Marc-Elian to explain us all about it, I would like to remind you that you can attend the lecture either from your computer or via tablets and phones using the Adobe Connect free application. And if you face any technical difficulties, just send me a private message in the chat and I can help out. For those who attend for the first time, the RHEA Lunch Lectures are an initiative within the company which brings together employees, clients and friends for informative talks on current developments within the space security and now cloud computing sectors. The objective is to raise awareness of our projects and the skills of our international team. You will have the possibility to discuss and ask any questions directly to Marc-Elian at the Q&A session at the end of his presentation. Marc-Elian, welcome.
Thank you, Paulina. Well, thanks a lot, everybody, to be online for this this lecture. I will be spending about 40-45 minutes going through some slides and hopefully have some time for interesting Q&A at the end, as Paulina said. So I'm Marc-Elian Bégin. That's a French-Canadian name, and people often call me MEB, M-E-B. So I'm co-founder and CEO of SixSq. And I'll be, like I said, taking the next 45 minutes to talk about cloud technology and in the first part, and in the second part, the product and services that SixSq has developed and is delivering in the cloud space. So it'll be two parts. So SixSq is based in Geneva, in Switzerland. That's where our head office is, and where currently all the development takes place. We've also opened an antenna in Montreal, in Canada, which we'll be using as a launch pad to some of our Canadian operations in the Americas. We were founded in 2007. Myself and Charles Loomis, CTO of SixSq, met at CERN here in Geneva, and that's where, with Louise Merrifield, we decided back then to create SixSq. And it was really at the beginning of the cloud era that we decided to do this, and I'll give you a bit of a history in a few minutes. But basically, the focus of SixSq is on cloud. That's what we do. It's nearly the only thing we do. We have built a wide neutral knowledge of cloud technologies, and I think there are very few companies, at least of our size, that can claim to have this neutrality in most or if not all cloud solutions out there. Which is important when we deliver solutions to customers. So as Paulina said during the introduction, we are now, since the end of last year, we're part of a member of the RHEA group, and this is where we bring the cloud practice in the group. And this is where I'm going to try to focus on for the rest of my talk. If we look at the cloud word that is shown in the new slide deck of RHEA, we see space and cyber security is important, but obviously cloud is now important as we deliver IT systems, and this is basically the focus of where SixSq is, and that's what we bring to the RHEA ecosystem. Our current customers, and this has been for the last 5 years, I would say, 5 or 6 years. on this slide. So we talk about, we work a lot with Atos, with ISA has been a historical a customer of ours, which is convenient because it's one of the key customers of RHEA as well. So it's a rich ecosystem we can bring together. We also work a lot with the European Broadcast Union here in Geneva. That's the Eurovision people, and a bunch of other small and large enterprises. We also work with CERN through the Helix Nebula initiative, and I'll talk about this in a few minutes as well. So cloud means many things. At the moment, it's like Paulina said in the introduction, it is a buzzword, and like most buzzwords, it's overloaded with a bunch of terms that are sometimes useful and sometimes not. So over the next few minutes, I'll basically focus on the origin of cloud technology, where it came from, and also what is the essence of cloud. At least that's the way I define it, or the way we use it here at SixSq. So in 2006, Amazon, so like in Amazon.com, the book online reseller, basically announced two key services in that summer. One is EC2, so it stands for Elastic Compute Cloud. And the second one is S3, or Simple Storage Service. And I'll explain a little bit what these things are, but basically it was the first time that on-demand computing was becoming commercially viable. If people, for the ones that maybe have my age or maybe even older, remember in the 90s there were many attempts by IBM, Sun Microsystems, and other large IT providers to deliver on-demand computing, but it, to a larger extent, although technically it had some value from a commercial standpoint, it never became a reality. It was too complicated, too complex to put in place, too heavy, and so on. And this is only when Amazon basically announced EC2 and S3 that cloud computing, as we mostly know it today, became a reality. So why is that? Let's try to explore this a little bit. So the essence of cloud computing is two very simple things put together that together makes the difference. One is virtualization, and I'll explain a little bit what that is. And the second one is a very simple API. So an application programming interface that can be used to actually provision virtual machines thanks to virtualization. So in essence, that's what cloud computing is about. Okay, virtualization and a simple API to actually manipulate those virtual machines. So what is virtualization? Just to be on the same page. Normally you have your hardware layer. That's your physical server on which you run an operating system. And in that operating system, you will be running one or several applications. Okay, that's the standard setup we've been running for ages. Now, virtualization is that we for example, replace the applications by another program called a hypervisor. And the beauty of the hypervisor is that it's a program that can run an operating system in which, again, you can run one or several applications. But what is really interesting and the key difference here is that you can actually run several operating systems in that on that hypervisor. There's different flavors of these things, and there's a few details that I'm not go into. But what is important here is that, for example, the operating system that we have at the top of this slide here can be different operating systems. So we can have, although you're running on a Linux OS, for example, you can easily mix and match Windows and other types of operating systems, so that you can create a much greater density of application. Another great benefit here is that we have, by doing this, we have separated the operating system that runs on the physical infrastructure from the operating system that runs the client or the user application. Okay, and that difference, that separation is key in order to provide a simple API to provision the OS and the application as a virtual machine. And also it allows you to be able to change basically at different rates the operating system, the patches as you upgrade your applications and so on. Okay, so we've sort of decoupled completely, or to a very large extent, the management of the physical infrastructure from the runtime environment in which the customer or the user is running his or her applications. Okay, and this is how a simple API can be created then in order to manage the life cycle of that OS application combination, which we call a virtual machine, going forward. So the simple API is basically just the idea of creating an API to provision, as I said, those virtual machines. And because of the combination of those two things, we were able to, or Amazon originally were able to create, set up simple contracts and governance, where before you needed, 100 pages and a bunch of lawyers talk forever before you could actually converge that access to those resources. And this is what made the big difference. That's why, because EC2 and S3 became the reference and the business that represents several billion whatever currency every year at the moment was at the origin was that simple combination of things. Okay, but if I talk to my grandma or people in the street, they'll, when you ask them what is cloud, often you get this answer, right? Cloud is, well, that's where I store my music or my pictures. So in many ways, the commercial war on terms around cloud has been won by Apple, if you want, or these storage solutions. So in order to declutter a little bit these overloaded terms, the cloud community or the cloud industry has defined some more specific terms that are useful when you're talking about, in general terms, about cloud computing. And I'll extract 3 of those that are important going forward in my talk. The first one is infrastructure as a service, okay, or IaaS or IaaS. This is what I've been talking about. It really is turning the nuts and bolts of your infrastructure in terms of CPU or core, RAM, network, disk, and so on, and make this a service via virtualization and a simple API I've described earlier. Now, these are just virtual machines. It's an operating system in where you can run applications, but that's no more than that. What industry has been working on for, I would say, more focused for the last 2 or 3 years is platform as a service. Is how do we take those fundamental building blocks, those virtual machines, and then combine them together and add the automation required in order to, if you want, elevate ourselves in the value chain so that you're not manipulating core, RAM, and disk storage, but you can start to automate things, start to work in terms of multi-virtual machines working together to deliver a distributed application, for example, a Hadoop cluster, a data processing engine, and so on. And this is where basically SixSq focuses with our Slipstream product, and I'll talk about that a little later as well. And on top of, once you have the infrastructure as a service, you have the platform where you can actually automate the usage of those fundamental bricks. Then you have the ability to deliver software as a service, like your Salesforce, or for example, Amazon.com, where you basically go to a portal on the web, then you consume something. That is in many ways, it's software as a service. You basically buy the service without having to install anything, and you often just pay, like in any of the cloud paradigm. You only pay for what you use, or pay for the storage or the data you leave behind once you've stopped using the compute part of that service, for example. So infrastructure as a service, platform as a service, and software as a service are the more specific building blocks in cloud computing at the moment. And this is where you basically see different companies and teams will position themselves in the cloud neighborhood, if you want. So where do we fit in this picture? So we being a small team, we're about a dozen people here in Geneva. We cannot live in a vacuum. So we have created a number of collaboration and partnerships. We are currently a technology partner as part of the Amazon Web Service Partner Network. So this Amazon Web Services is the Amazon company that looks after the EC2S3 and a bunch of new services that have been added over the years by Amazon. We have IBM here in Geneva, especially. We have a great relationship with IBM. Helix Nebula, I'll talk about a little bit later, because there's a great synergy with work that is being taking place at the European Space Agency and CERN next door. And also Exoscale, which is a small public cloud that is producing a very interesting infrastructure as a service solution that we are taking advantage of more and more going forward, and building together solutions for customers. So in about 2010, something called Helix Nebula was born. Helix Nebula, some of you might have heard in different contexts, but basically the initiative was initiated by CERN, EMBL, and ESA, and lately PIC and ECMWF have joined force on the demand side. And the original idea was to, for those big labs and big consumers of IT resources, basically challenged the European industrials, saying, why can't we spend large-scale cloud resources here in Europe, where the leaders in the market are, for example, Amazon, Google, or Microsoft? And this initiative basically was created to try to foster this collaboration and this response from the European industrial partners. So we were invited by CERN as subject matter experts back then. And then over the couple of years of working together, we realized in 2012 that our flagship product, Slipstream, could actually be used with a few changes, upgrades, as a broker that would sit on top of the cloud, the infrastructure as a service solution that the different cloud providers in Europe were providing, so that you could have a federated, large European cloud. Okay, so that was the trigger, and this is where SixSq invested heavily, especially with the support of Atos in this context, to get into Helix Nebula and create what we call the Helix Nebula marketplace. This is this HNX on this slide. So sorry. So here the idea is that CERN, ESA, and EMBL, for example, can come to a single interface, a single broker, and then provision small or large scale cloud resources that will then be deployed on, for example, here I've illustrated T-Systems, Exoscale, Ultimum, or Atos. So these are different companies that provide infrastructure as a service solutions. And the customers could come to this simple single interface and then decide on which cloud they wanted to provision, knowing that they would see no difference in the implementation. Because if you look at the detail of how T-Systems, Exascale, Ultimum, and Atos are deploying their clouds, they're actually using completely different solution. And for instance, T-System is using VMware vCloud. Exascale is using CloudStack. Ultimum is using OpenStack, and Atos is using StratusLab, which includes OpenNebula. Different proprietary and open source infrastructure as a service solutions, but providing comparable infrastructure as a service services that are then federated and harmonized through the Helix Nebula marketplace, that layer in the middle. And this is what, to a large extent, what SixSq is delivering with Slipstream, our platform as a service solution. We also have extensions working with the server labs that are providing an EC2 bridge so that you can even talk to the marketplace as if it was an Amazon cloud. If that's which is the case for EMBL, for example. Okay, so there's different ways of doing this. But the beauty here is that although we're connecting a growing number of heterogeneous cloud capabilities, it is being used or consumed by the customer as if it was the same. So now diving a little bit into how is the European Space Agency using Helix Nebula as part of its pilot program that has been going on for the last 2 or 3 years. So ESA is focusing in this case on Earth observation data analysis. Okay, and the idea there is to automate cluster deployment or cluster provisioning so that data can be analyzed in a more dynamic way, in an easier way, with the ultimate objective to create a new business model so that small and medium and large enterprises can more easily add value to Earth observation data. In the context of ESA, that data has been paid by the European taxpayer, and the idea is to make sure that we can facilitate extraction of value from this data by providing a very dynamic IT infrastructure, not only to mine the data, but also to share algorithms and applications that can actually manipulate this data in new ways. So the solution, it's a one-click parameterized processing cluster deployment that's been captured in the marketplace in Slipstream, and the ability to create automatically new virtual machines and create things like distributed file systems to store data, to facilitate those types of tasks that are typically very time-consuming, can be error-prone, and requires a fair amount of specific knowledge in different domains, which would be very difficult for a single team to acquire, especially if it's an SME. Okay, so it really is to make this process of data processing much simpler and without requiring heavy upfront investment into hardware, for example, thanks to cloud computing. So if to make the story very 36,000 high picture of it, the idea is to basically provision automatically in cloud environments a compute cluster, which would then be able to access data through a data cluster that would also be provisioned automatically in very simple ways, so that a scientist or a team could say, okay, I want to run that algorithm on that data set, go, and then tell me when the results are available, and allow this type of processing to be to create new products and services that could be sold to a wide range of stakeholders. Okay, and that's what the tooling that we're developing allow now users to do. What's also interesting is that thanks to our technology, the same simplicity we have to provision compute clusters, for example, will work across clouds. So a user could provision a complex application representing those compute and data clusters into more than one cloud to achieve economy of scale, for example, higher resilience, savings, and so on. Okay, without having to recreate everything from scratch because they're changing from one cloud to another. So let's have a quick closer look to Slipstream, which is the product and service that SixSq has been working on for the last 7 years. So in essence, as I said before, Slipstream is a platform as a service. Okay, so it is this layer sitting on top of infrastructure as a service that provides this automation capabilities to the end user. In 2012, we've open sourced Slipstream, so the core of it is now available under an Apache 2.0 license. It is multi-cloud, as I said, but it's also multi-tenant, so it's enterprise ready, where different users can actually have can be segregated inside the same Slipstream instance, and they also have the ability to share deployment recipes, results, and so on. So in Slipstream, like I said, platform as a service is where we sit. Another way to look at this, Slipstream is a platform as a service that uses infrastructure as a service, as I was illustrating earlier in the case of Helix Nebula. But it's also delivered as a software as a service in the sense that the main user interface is web-based. Okay, from version 2.4, it's even dynamic, so it will work on desktop, but also tablet or phone. So here is a screenshot of the App Store, the part that a user could come here and then say, okay, now I want an open ERP or a simple operating system or a WordPress, and so on. And there's a mechanism to share those deployment recipes between users in a very simple way. Here's a quick screenshot of the dashboard showing in here that I've got 5 virtual machines running at EC2 EU West, which is in Ireland, and 1 virtual machine running at Exoscale here in Geneva. This is for the web part. The application can also be used through a command line client that can be installed. It's a Python command line client that can be installed with pip. But behind this, Slipstream, in essence, is a RESTful web service, and we have a fully documented API so that users can integrate the engine of Slipstream through the API. Now, how does Slipstream manage to interface with so many different infrastructure as a service solutions? And the answer to this is through our connector architecture. So Slipstream has a concept of dynamically loaded connectors. So when you configure Slipstream, you can activate those connectors. And we basically distribute we sell Slipstream licenses in a very similar model as Red Hat, with a number of connectors that are open source, like the Cloud Stack, the OpenStack connectors, for example, here. But we also have proprietary connectors like Cloud Sigma, VMware, Amazon, for example, or IBM solutions. And the reason why some of our connectors are open source, while the others, some are proprietary, it's very simple. Typically, although there's a few exceptions to this rule, if the cloud solution we're talking to is open source, then we open source the cloud connector. If the solution is either closed or it's a proprietary service, like in the case of Cloud Sigma, then we make the connector proprietary. But we will provide professional services to all of the types of connectors we provide with the Slipstream instance as well. So in a nutshell, what are the main attributes? So open source I described earlier. It's professional open source software, meaning there is a professional team focused here in Geneva that will basically, that is continuously developing the solution. And this is from that team that we also provide professional services, expert support, and so on. I think I've mentioned multi-cloud several times already. So is multi-tenant. What is interesting from an automation standpoint, as I said before, is the ability to say, to curate after a QA process some of the deployment recipes that we can apply to create, to deploy an application that can be as simple as a WordPress, for example, or as complex as SCOS 2000 or an SAP plus DB2 system that will be deployed on a number of virtual machines, if not on a number of virtual machines on several clouds, as I was illustrating with the ESA compute cluster example earlier. It's also scalable in terms of number of users with number of resources. We currently have CERN, for example, deploying and managing several thousand virtual machines using Slipstream for in the context of HNX, which is has been great feedback for us to improve the scalability and the fault tolerance of Slipstream over the last few months. So what can we do with this? Use cases that we can implement using Slipstream, and something that I haven't spoken too much about, because although some people make a big fuss about it, I personally don't, is whether we should go public cloud or versus private cloud or hybrid. I think in many ways, once we understand the technology, the capabilities of it, then to a larger extent, whether you go public or private, it's a question of governance, of policy, of data access, and so on. So I think understanding some fundamentals in cloud computing technologies will deambiguate to a larger extent the benefits, the advantages, and the disadvantages of building your own private cloud capabilities versus using public cloud or semi-private cloud services, and when it makes sense to use both. Okay, so just to put maybe that case aside, and we can talk about it a little later during the Q&A, because there's also security aspects that come in this trade-off as well. So enterprise app store or self-service IT, the idea is to simplify the way for a team or a project to acquire resources from the organization, and also avoid, for example, shadow IT, where it's sometimes so difficult within an organization to get access to IT resources that some people will just say, I had enough of this, I'm taking my credit card and I'm going to go and buy some virtual machines from Amazon. And then the CIO of the company is pulling his hair out because it's creating a huge hole in the IT organization. So hybrid cloud provisioning, by the beauty of being able to have Slipstream talking to more than one cloud at a time, then you have the ability to enable a private and a public connector, for example, then decide in a very fluid and dynamic way which workloads will go on the private cloud and which one will go on a public one. And then it also gives you access to bursting. You have a peak of demand, a peak of data processing, for example, and it's easy to actually burst out to a public cloud without having to invest in further hardware for private capabilities. In many ways, simplifying the way you provision simple virtual machines is great, but if you look at the total cost of ownership and where a team will spend time going from a year into something that isn't production, it's often the system, the idea of deploying, configuring the application and so on. That's where a lot of time is spent. So
Marc-Elian,
yeah.
I'm sorry for the interruption. Just to tell you that some attendees have problems hearing you. If you could please speak a bit louder. Not everybody has the same microphone settings, of course, but it would just help if you
Okay, so if
go
I bring the
closer to the
microphone
mic.
closer, is that better?
Oh, yes, that's much better. Yes.
Okay, sorry about that.
Thank you
Okay.
very much.
Yeah, thank you. Yeah, thanks for the interruption. Sorry for the folks that hopefully didn't miss too much of what I was saying before. Yeah, so basically the ability to deploy application continuously and in a very simple way will actually bring a big saving in time and effort and increase in quality. Which brings me to the DevOps concept. I'm not going to get into the details of DevOps, but in a nutshell, DevOps is, if you want, it's an agile methodology that doesn't only focus on the development lifecycle, but includes the operations part of the life cycle, which means that we need to fluidify the way applications are deployed, and this is where automation plays an important role. The cloud marketplace is similar to the idea that I explained with the Helix Nebula marketplace. And lately we've been working hard on auto-scale and mutable deployment, where an application can be described in Slipstream such that it can more easily grow and shrink based on demand or other key performance indicators, so that, for example, your cluster will grow and shrink as a function of the size of your queue, for example, or the number of users that are requesting, for example, downloading data from a website and so on, so that you can actually build all of this auto-scale logic inside the system and then apply that independently to the cloud of your choice. Now, I've been talking about Slipstream a lot, and I might even have a couple of minutes to give you a quick demo. But last year, we've combined two software solutions that we've been working on, so Slipstream and then StratusLab. StratusLab is it's an infrastructure as a service solution that includes OpenNebula, for example, was funded by the 7 Framework Program. It's European funding, where we had the chance to develop an infrastructure as a service solution from pretty much the ground up, which is where a lot of the learning that we have now in the team comes from. And what we've done is we've taken those two solutions together, and instead of doing the very large big data type of application that we do with Helix Nebula, we went the opposite direction. Okay, and the result is creating the Nuvla box. And the Nuvla box is an embedded fanless PC that looks like this. If you look on our website, we say it's the size of 2 Swiss chocolate boxes, and it is it's a microcloud. It's a cloud in a box. Okay, it can run up to 8 virtual machines, but it's fully turnkey. You plug it in the wall, you switch it on, and then you have a small cloud that will establish its own Wi-Fi by default. You can remote control it as well, which is interesting. Just to show that being a bit creative, we can reuse the same technology to go from very big to very small, but bring all the convenience and the automation that we've been working on. Here is a few details on what's inside. What's interesting about the Nuvla box is the fact that it is fanless, so there's no moving parts. It's a very sturdy, robust machine, and has that spec. You can look on the website to have further details. But what's also interesting here is that we can remote control those boxes, right? From Slipstream point of view, a Nuvla box is just yet another cloud. So you could have, dozens of those things out there, and being able to remote control the applications and the virtual machines running inside of those Nuvla boxes. The only difference is that instead of being an elastic, like a very large pool of resources, it is very constrained. But if you remove that constraint, you know, you can actually look at manipulating those Noodle boxes as clouds. Is very interesting, and we're exploring, especially as of lately with RHEA, a number of industrial applications that are looking very, very interesting indeed, to solve some existing problem with in novel ways. So what's next? I think the beauty, and this is why myself and my team are very excited about this new partnership, is you know, going forwards, building new value together, cross-fertilizing our capabilities, and addressing new markets with new offers, or existing markets with new ideas, and then building best-of-breed solutions all together. So this is, if you have an invitation to my new colleagues inside the RHEA group, please do take this as an invitation to basically challenge ourselves to come up with the next big ideas that will make a difference. I think I have just enough time. Well, maybe some of you guys prepare perhaps some questions to give you a quick demo. So here I'm on slipstream.sixsq.com. That's the SaaS of Slipstream. This is what we use for demonstration, for example. So you can create an account yourself. It's free. And then configure your account to talk to a number of clouds that are configured. Here, what I would like to do, I've just logged in. I can go to the WordPress part of the App Store. These have been curated by ourselves in this case. And I can say, okay, now the WordPress, I'm going to click on the deploy button, and it's going to bring me this form that I can fill. It's going to say by default, I'm going to be deploying on exascale. I want to keep that running once it's been deployed, and I'll change the title of the WordPress, which is a blog application. Hello from RHEA lecture. Okay, and then I say run, and it will basically deploy and provision this WordPress at exascale, the same way as I could have done the same at Amazon EC2 or any other cloud that was configured on this instance of Slipstream. So that's going to take a few minutes. During that time, we can I'll stop, and maybe we can take some questions from the audience. Any questions? Patrick is typing.
Thank you very much for the demonstration, Marc-Elian.
You're welcome. So, by the way, what's happening here is that Slipstream is going through its provisioning stage. So it's starting the virtual machines, and when the virtual machine has been started, it will basically then execute what we call a recipe, which will install actually the WordPress application on the operating system, which I think is based on Ubuntu in this case. Okay, and once it's ready, it's going to tell us where to log in and so on. So Patrick is saying, hi, any thoughts about how RHEA's infrastructure could be moved or migrated to your cloud infrastructure? Okay, well, thanks for the question. Just one clarification before we move forward. SixSq doesn't have an infrastructure, right? We provide software that we deploy in public or private cloud infrastructure or on customers' premises. Okay, so if I may rephrase your question, any thoughts about RHEA's infrastructure could be moved or migrated to a cloud infrastructure? Yes, absolutely. We have we have started a task to basically review current needs of RHEA in terms of applications, and then decide basically if there is a need to have those rehosted in a cloud environment, and if so, would it be a private or a public cloud service, or using a software as a service solution for sometimes CRM, ERP applications are interesting candidates. But anything that has to do with, for example, build and test environments, your Jenkins and your type of dynamic deployments that you need to accompany your projects, yeah, we have definitely ready recipes in Slipstream that can be used to provision those types of services in either private or public clouds. So this is definitely something that we are going to be reviewing and months together.
I can see there are more people typing.
Yeah,
but just to mention that
yes.
If someone wants to also use their audio, I have activated the participants' rights for the microphone use. So if someone wants to also ask directly, but of course the chat is also good.
Mm-hmm. So just before I answer your question, Giovanni, now the deployment is ready, and now the service is telling, the Slipstream is telling me that the service that I've provisioned is available here. So if I go to this link, then it's going to tell me, it's going to show me the WordPress that was deployed and configured according to the parameters I gave in the form, which changes basically the title of the WordPress to Hello from RHEA Lecture, just to show that it was not a fake demo. The only thing, once I've done that, I can actually terminate the application. I can now show the resources that I'm currently using in the dashboard of Slipstream. Voila. So Giovanni is saying, thanks a lot, Marc-Elian. You're very welcome. What would be a typical solution for cloud computing at ESA requiring confidentiality of information from ESA or industry? Yeah, great question. As you can perhaps predict, my answer would probably start by, it depends. There are some very secured applications that have been deployed in public clouds. So we would have to look into the details. I know for sure, we've been going through together to a number of sites of ESA, that there are a number of initiatives that ESA is following. So there is more than one private clouds that are being deployed. If you look at SixSq, Esrin, ISAC, etc. And some of those sites have more than one in their own respect. So assuming that the confidentiality is extreme and that the data needs to stay on premise, then we would use a private cloud solution. If we wanted to mitigate single site in terms of availability of data and so on, we could look at encryption of data disks that could be applied to public clouds or private clouds. There's also strategies. Now I'm getting into cybersecurity, and this is a domain that RHEA has greater expertise, which is something that we're also quite excited about exploring together going forward, is to basically share secrets across, or shard, if you want, the secrets across different sites, so that if one site was compromised, you couldn't get the full picture. So there's a number of things to consider and options that are available. But I think the three fundamental options are full private, full public, or hybrid. And from experience, hybrid seems to be a great way to mitigate security, yet have access to scalable resources. Giovanni saying thank you, and you're very welcome. Any more? Okay, I don't see anybody. Oh, yes. Is SixSq collaborating with, so this is a question from Tristan, is SixSq collaborating with ODCA members? We are collaborating through Helix Nebula, where we are in contact, and we have a number of initiatives with Atos, who are, I would say, heavily involved in ODCA. So we've been sort of following some of those best practice through a number of discussions we had with Atos. We are not engaged directly with ODCA. This is something that is probably valuable to at least review and see if there's value there, whether we should be engage ourselves or at least position ourselves with some of the results that are coming from ODCA. And just for benefit of everybody else, from a memory, ODCA stands for Open Data Center. I don't remember. Have a quick look. I can beat you. Central Alliance. There you go. You beat me to it. Okay. But if you have Tristan, if you have inputs into this or thoughts, I'd be interested to hear them.
Let's see if there is any more question coming. I don't see someone typing. We have a couple more minutes.
I mean, in the meantime, I would be very interested of hearing your thoughts about well, the presentation and see the extent of the hoping that it was reasonably clear what would be potential usage of our technology, potential holes that we would have to fill in order to get into a better position where you see a potential and so on. So I'd be very interested to hear your thoughts about that as well.
Nobody dares to make the beginning, I suppose. I think it was a very interesting presentation. It was very nice that you could also take the time to make the demonstration at the end of the slipstream. And users now, that the attendees can also go and test it by themselves, as you showed. They can just create an account and log in and see how it works.
Absolutely. And our support team is there to answer any questions and so on. Oh, by the way, may I make a plug? There's end of April, we're running a training course of 2 days here in Geneva. I think it's the 24th and 25th, or the 23rd or 24th, around those days. If anybody's interested in joining, there are a few seats left.
I see an activity. Everybody's typing. Here it is. One.
Yeah. Okay, Giovanni is saying, I'd be very interested in discussing offline potential solutions for our computing needs for ESA simulations of space radiation environment. Absolutely, yes. Please reach out, Giovanni. And Louise is confirming that the training in April is the 23rd and the 24th, and it will be here in Geneva. It will be announced, I think, early next week, more widely.
I don't see more questions, I think, coming. Thank you very much for the invitation, also for the workshop. And I suppose we'll send invitations by email to explain more about it for those who are interested in participating. And thank you for taking the time today, Marc-Elian, to give us an introduction to cloud computing and to present briefly the activities of SixSq and RHEA in this innovative domain. And to all attendees, thank you very much for